Hello and welcome back to my channel. Today in this video we are going to discuss another past year paper of mathematics from Cambridge International AS and A level, and it is probability and statistics 1 from May-June 2021, and it is 9709. The component is 5.2. So let's start with the question number 1. So the first question is, an ordinary fair die is thrown repeatedly until a 5 is obtained. The number of throws taken is denoted by the random variable x. A part is write down the mean of x. We can see that we are here actually repeating this unless and until we get a success, and success here is to obtain a 5, so it is geometric. So we can see the probability, success probability for geometric, since the geometric is GEOP, where P is the success probability, and here the probability of success probability is getting 5 from the dice. So we know it is 1/6, and mean of geometric distribution is simply 1 upon mean is 1 upon p. For geometric distribution, it is always going to be 1 upon p. So here the 1 upon p, the reciprocal of 1/6 is simply 6. So the mean of x is 6. And in B part, find the probability that a 5 is obtained after the 3rd throw but before the 8th throw. So if we denote it mathematically here, so we can see this x satisfies geometric distribution we have seen, and the success probability p, which is actually 1/6. So our probability which we need to find is probability of x, number of trials required to get the first 5 at first is more than 3, so it is greater than 3 and less than 8. So this is what we need to find. It means we need to find the probability for when the number of throw is to get a first 5 is either 4, 5, 6 or 7. So these are the value we can search for getting the first 5. So we can see in the probability geometric distribution, first to get the first 5 in the first 4th throw, it means the first 3 throw was not 5. Not 5 means 5/6. So first 3 throws were not 5 means power 3, and 4th throw is 6, so 5, that is 1/6. Similarly, so we need to calculate this. So in order to calculate this, I would store 5/6 to one alphabet, let's say A, so that it would be easy to calculate, and 1/6 to alphabet B. So now in order to find this, it means we are going to calculate a to the power 3 multiplied by b, which was 1/6, plus a to the power 4 multiplied by b, and a to the power 5 multiplied by b, plus a to the power 6 multiplied by b, because a, we have seen a is 5/6 and b is 1/6, so we can see this answer is 0.2996 and so on. So till 3 significant figure we can give this answer as 0.300. That's the answer, that's the probability. And here's the C part. Find the probability that a 5 is obtained in fewer than 10 throws. So here we need to find the probability of x less than 10, because we need to find the probability of getting a 5 in fewer than 10 throws. So we will simply use 1 minus, we are not getting probability of not getting a 5 in first 9 throws. because if we are not getting a 5 in first 9 rows and we subtract it from 1, it means we must have got a 5 in any of the step, any of the row from 1 to 9. So it is 1 minus not getting, so it is 5 over 6 and to the power 9. And now we will calculate this value directly from calculator. 1 minus 5 over 6 to the power 9. This value is 0.8061 and so on. 0.8061 and so on. So till 3 significant figure, this is the answer. And in the second question, the weights of bags of sugar are normally distributed with mean 1.04 kg and standard deviations sigma kg. In a random sample of 22,000 bags of sugar, 72 weighed more than 1.10 kg. Find the value of sigma. So it is normally distributed. So for normal distribution, we have the parameters which we require are mean, which is 1.04, and standard deviation sigma, so it is sigma square because it is always variance, that is standard deviation square. And here the question suggests that in a random sample of 2000 bags of sugar, for 72 weighed more than this. So we can find the probability for 72 bags first of all. So our probability is going to be 72 upon 2000. So, and 72 upon 2000 is 0.036, and it means now we can convert it into our usual form. The probability suggests is x more than 1.10 is 0.036, and we know that if it is greater than, so if we convert it into standard normal distribution, so it would be probability of z greater than 1.10 minus mu upon sigma is going to be 0.036. So I will draw this diagram. Here this 1.1 kg is going to be here, 1.10 kg is here, and more than this probability is 0.036. So if we subtract, or if we see this area, then it is going to be 1 minus, this area is going to be 1 minus 0.036, which is 0.964. So now we can convert it. Probability of z less than 1.10 minus mu we have, it is 1.04 upon sigma, and this probability becomes 0.964. We could not see the value of z from 0.036 because it is just 3.6%, because and in the table it is always more than 50% given. So now we can calculate by taking the phi inverse, because this thing become phi of the whole, phi of z. So it is 1.10 minus 1.04 is simply 0.06 upon sigma, and then it would be phi inverse of 0.964. And now we will see the from the distribution table, normal distribution table, what does this value gives as the z value, so that we can calculate our sigma. 0.9633 and 0.9641 is here. Before that 33, if we include 7 into it, means this one, then we will get 0.964 exactly. So our value of z is 1.73 from here, 9 from here, and 8 from here. So it become 1.798. so this is 1.798. so now we'll calculate sigma, and here we can see sigma is 0.06 upon 1.798. 0.06 divided by 1.798, which is 0.3337. so 0.0333, and lastly it is, I will write till 3 significant figure and it becomes 0.0334 kg. That's the sigma, that is standard deviation value of sigma. I hope it is clear. Let's discuss the next question. In third question, on each day that Alexa goes to work, the probabilities that she travels by bus, by train or by car are 0.4, 0.35 and 0.25 respectively. When she travels by bus, the probability that she arrives late is 0.055. When she travels by train, the probability that she arrives late is 0.7. When she travels by car, the probability that she arrives late is x. On a randomly chosen day, when Alexa goes to work, the probability that she does not arrive late is 0.48. She does not arrive is 0.48. A part is find the value of x. So the information is given for does not arrive, and everywhere we can see they have given the probability for arriving late and arriving late here. So in either we can use the formula for not if arriving late is given 0.55, so arriving not late is going to be 1 minus 0.55. so it's better to start with the late, so because we need to just find the value of x. So probability of being late is going to be either by bus and late, or by train and got late, or by car and got late. So this is the probability of arriving late. So 1 minus of this probability is given as 0.48. So in place of subtracting this 3 probability from 1, we can simply subtract 0.48 from 1. That would be easier. So it is 1 minus bus, from bus 0.4, and arriving late means 0.55, or means plus by train, that is 0.35, and arriving late is 0.7, or by car, that is 0.25, and arriving late is x. This is 0.48. Now I'm going to transfer this whole thing to the right hand side as 0.48 to the left hand side, and we know we will subtract 0.48 from 1, so it becomes 0.52, and this whole thing we will calculate. 0.4 into 0.55 is 0.22, and plus 0.35 into 0.7 sorry 0.7 is 0.245, and lastly it is 0.25x. so 0.25x become 0.52 minus the sum of these two, which is 0.465 and subtracting 0.5 to 0.465 from 0.52 we will get 0.055. So from here we got x value as 0.055 upon 0.25. You can calculate from calculator. This value is coming 0.22. So either we can say that the value of x is 0.22, and in otherwise we can say whenever she travels by car, the probability that she arrives late is 0.22. In B part, find the probability that Alexa travels to work by train and given that she arrives late. So it's a conditional probability. So we can write our situation or probability, we can write as travel by train given that she is late. So by the formula of conditional probability we can say it is probability of T intersection L, means traveling by train and getting late, and divide by probability of being late. So traveling by train, we can see from the question, traveling by train and that is 0.35 and getting late is 0.07. So traveling by this is 0.35 multiplied by 0.7, not 0.07, I said 0.07 lastly, 0.7 divide by probability of getting late, which was given in the question itself, previous part, it is 0.48. 0.48 was upon being late, means probability of getting not late was 0.48, it was given in the question. So late is going to be 1 minus 0.48. So now we will calculate this. 0.35 multiplied by 0.7 divided by 1 minus 0.48, it is 49 over 104. In decimal it is 0.47115 and so on. So this value is 0.47115 and so on. So till 3 significant figure it is going to be 0.471, and that's the answer, that's the probability. Fourth question, a fair spinner has sides number 1 to 2. Another fair spinner has sides number -2, 0, 1. Each spinner is spun. The number on the side on each spinner comes to rest is noted. The random variable x is the sum of the numbers of the two spinners. So x is the sum of the numbers of two spinners. A part, draw up the probability distribution table for x. So I will make a table first. Before that, I think we should decide what would be the values of x. What can this random variable take? What values? So since it is a sum, so for the sum we can see the minimum. For the minimum, if on the second spinner we are getting, let's say, -2 and we are getting 1 in the first spinner and we add, it is -1, and any other possibility, if you see, it will always be more than -1. So that's the minimum. And for maximum, if you see 1 from the second spinner and 2 from the first spinner, and when we add them we are getting 3. So it will start from -1 and it can take the value, x can take the values from -1 to 3. So here it is going to be, let's say, x, and it is going to take -1, 0, 1, 2, 3, these values, and we'll see if it is any of it is not possible or more possibilities are there. So for the probabilities, we'll write x greater than small x. These are the values. For -1, what are the possibilities? If we get 1 from the first one and another it is -2, then only we'll get -1. So getting 1 from the first is 1 by 3, and getting -2 from the another is again 1 by 3. So this is simply 1 by 9. So it is 1 over 9. For 0, first is if we are getting 2 in the first spinner and in the second we are getting -2, then it would be 0, otherwise it's not going to be 0. So from getting 2 from the first spinner is 2 by 3, and getting -2 from the second one is going to be again 1 by 3. So it is 2 over 9. And for 1 there is a possibility if we get 1 from the first spinner and second spinner we are getting 0. Anywhere else it is not possible, so this is the only possibility. And for 1 it is 1 by 9, and for 0 again here, sorry, 1 by 3, and here also 1 by 3, so it is 1 over 9. And for 2, it is possible only if we get 1 from the first one and second one, or if we get 2 from the first spinner and 0 from the second spinner, then only we'll get 2. So for first case, 1 means 1 by 3, another one is 1 by 3, and or this is the case when 2, it means 2 by 3, and 0 means 1 by 3. So it is 1 by 9 plus 2 by 9. 1 by 9 plus 2 by 9 is 3 by 9. And lastly, it is 3. 3 means we are getting 2 from the first spinner and 1 from the second one. I guess that's the only possibility. So it is 2 means 2 by 3, and 1 from the another is 1 by 3. So it is 2 by 9. And finally, we can check whether we have done it correctly or not by adding the probabilities. It has to be 1. So we can see 1 plus 2, 3 plus 1, 4 plus 3, 7 plus 2, 9. 9 upon 9 is 1. So it is fine. So this is the probability distribution table for X. Here's the B part. Find expectation of X and variance of X. And for this we need that distribution table. So for expectation, we know it is -1 into its corresponding probability plus 0 into its corresponding probability plus 1 into its corresponding probability plus 2 into its corresponding probability plus lastly 3 into its corresponding probability. So we got it as -1 over 9 plus 0 plus 1 over 9 plus 6 over 9 plus 6 over 9. -1 over 9 plus 1 over 9 is 0. 6 plus 6, 12 over 9. So it is 12 over 9, or we can say it is 4 over 3. So we can either write 4 over 3, or we can write its simplified form, which is 1.33 and all. So for the final answer we can write 1.33 till C significant figure. And for the variance, we are not going to use 1.33, we will use 4 over 3. But before that we should know the formula for variance. Variance of X is expectation of X square minus square of expectation of X. So we have already this expectation of X, so we need to find the expectation of X square, which is the square of the values and its corresponding probability. So -1 square into 1 by 9 plus 0 square into 2 by 9 plus 1 square into 1 by 9 plus 2 square into 3 by 9 plus 3 square into 2 by 9 minus expectation of X square, that is 4 over 3 whole square. So we will calculate now. 1 square 1, so it become 1 over 9 plus 0 plus 1 over 9 plus 4 into 3, 12 over 9 plus 3 square is 9, 9 into 2, 18 over 9 minus 16 over 9. So we can calculate either by calculator or it's simple here. So 1 plus 1 2 plus 12 12 and 18 is 30 plus 2 32 32 upon 9, and here it is 16, so minus 16 upon 9. So finally we got it as 16 upon 9, and that's the variance. Or we can write its decimal equivalent till C significant figure. This value is 1.7 1.777 and so on. So we can write variance of x as 1.78 till C significant figure. So that's it for this video. I hope it was of some help. So let's meet again in the next video for the rest of the solutions. Till then, thank you so much.